All right, let's talk about birds. So we're into chapter 18, the endothermic vertebrates. So these are vertebrates that are warm-blooded. In other words, they can regulate their body temperature. So they have ways of raising their body temperature when they need to, and they have ways of dissipating heat in order to lower their body temperature when they need to. And in particular, chapter 18, part A, we're in class Aves, also known as the birds. So, what do we got? First of all, key characteristics. One of the first things I'm sure comes to most people's mind when they think of birds is flight. And there are some characteristics that help make flight more doable for birds. These are a few of them. One of them is hollow bones. Birds are very light, and they need to be light in order to obtain flight efficiently. And one of the ways that they are able to be nice and light is their bones have air pockets all throughout them, and they have basically hollow bones is more like a significant amount of the inside of the bone is somewhat like a sponge, not in being like squishy like a sponge, but in having a bunch of air pockets like a sponge. So hollow bones, but then also no teeth. Teeth are relatively heavy, and so one reason birds don't have teeth is to make them again lighter in order to make flight more doable. Instead of teeth, they have a beak, and the structure of a beak just serves some good functions. We'll talk about that later. But then also, the substance that beaks are made of is a lighter, still strong and firm, but less dense material, not as heavy of a material as teeth. But then birds are also oviparous. Oviparous again meaning laying eggs. How does that help with flight? Well, it makes it so that a mother bird doesn't have to be pregnant and carrying, trying to be pregnant with multiple babies developing inside of her and flying while doing that. So instead, lay eggs. That keeps the mother bird nice and light in order to still fly. And then also just lots of energy. What I mean by that is flight takes lots of energy, and so birds have to consume and expend a lot of energy in order to fly. But birds are designed to be able to do that. If we talk about like consuming food in order to get the energy that they need, an average bird eats about twice its body weight in food per day in order to get the energy that it needs to just keep on living. There's stuff about heart and respiration as well that plays a role in that we will talk about later. Feathers of birds. Another key characteristic is having feathers. And first, we have the main parts of a feather. There's the quill, the rachis, and the vane. We'll see in a picture in just a moment that the quill is still a term that is used, but there's another term that is for kind of part of a quill that is commonly used. I'm going to hold off on discussing what the rachis and vane are until we look at the picture on the next slide. And then types of feathers. So there are two main types of feathers that birds have. There are down feathers and contour feathers. And the main difference, and we'll see this in the next picture as well, is that feathers have like hooks and barbs. Think almost kind of like Velcro, because Velcro have like little hooks and then little loops that the hooks latch onto. A very similar thing is going on with the with the feathers of birds, but the hooks and barbs serve the purpose of helping the feather to maintain its shape, and in particular, the shape of contour feathers. So, contour having a connotation of a certain shape to it, and like contour lines. Yeah, so contour feathers, the hooks and barbs are connected to each other to help maintain the shape. Down feathers either lack the hooks and barbs or the hooks are not attached to the barbs. They're not grabbing or holding onto the barbs. And what that does is it allows down feathers to not maintain any particular shape. And the result of that is they're a lot more fluffy. So think of like a down pillow or a down comforter. That is a pillow or comforter that is filled with down feathers. It's this type of feather. It's the non contour feathers of a bird. And the main function that they serve is helping to keep body heat in. So you have a homework question, for example, that talks about ways that birds regulate their body temperature in the form of keeping heat in and in the form of releasing heat. And the main way that they keep heat in, or the main way that they help raise their body temperature, is the down feathers. Down feathers are a fantastic insulator. And as you would guess, because of what we talked about with flight, they're very, very light. And still to this day, if you have something like a coat, like a jacket kind of coat that is insulated or filled with down, it is going to be one of the lightest and best insulating type of jacket that you get. I think we do have some synthetic substances that are better than down at this point, but for a long time, down was the best, and down still is one of the best at insulating. So you can also get like very, very cold weather rated sleeping bags that are down sleeping bags, stuff like that. Okay, so down feathers help trap the heat in. And then contour feathers, one of the main types of contour feathers are the flight feathers, but they're also contour feathers that are not directly used for flight, but those are the shaped feathers. And then the way that birds care for their feathers is preening. And preening is like if you've seen a bird where it turns its head around kind of backwards and like rubs its beak on part of its body, and then it like, kind of pecks at and kind of rubs on its feathers with its beak. That is preening. And one of the things, well, there are a few things that are going on with preening. One of them is just helping to straighten the feathers and arrange them, and also helping on the contour feathers, all of the barbs, all the hooks and barbs to be properly kind of locked in place. But then the other thing that is going on with preening is there are some glands on the back of the bird that secrete a type of oil, and oftentimes when the bird is preening, it first wipes its beak on those glands and picks up some of that oil, and then it rubs that oil on the feathers, and it helps keep the feathers from becoming brittle and helps protect the feathers from damage from water, as some of what's going on there. Okay, so some pictures here. The rachis is the shaft part where the vein is found. So the vein would be similar to the blade of a feather, if you recall that term from earlier. So the vein is this part, and then the rachis is this part. And then the quill kind of extends a ways along here, but the end of the quill that is just the tip where there's no vein connected to it is called the calamus. Okay, and then you have similar thing here. If this picture is helpful, you have the vein over here, you have the rachis along there, and then the end there, the calamus. But I believe if you take the calamus and the first little, or it might just be this part along in here, the kind of the hollow part of the rachis that is the quill. And then some different representations of the barbs and barbules and the hooks. Here you have like, these hooklets, and then a barb. So the barb, so I like this one here. So you have that box right there, and then zoom in a bit, and you have, that's the rachis right there. And then you have these barbs that extend out, and then extending out from the barbs are barbules. And then on the barbules, there are hooklets. And the hooklets grab onto barbules and barbs and help maintain the shape of the feather. All right, so speaking of flight, a couple of videos that we'll watch, and we'll move on to the next topic.
This is the peregrine falcon, one of nature's boldest predators. For thousands of years, humans have admired its powerful wings and fiery spirit. But one quality above all sets this bird of prey apart. When it comes to raw speed, no creature on Earth can match it. Commercial pilot Ken Franklin raises and studies falcons to see how they live and how they move.
What characterizes a peregrine falcon is its pure ability to hunt at high speed in the open airspace. The more that I was involved in flight with birds and started seeing their speed, the more I really was driven just to be basically on wing with them.
But experts can't agree on the peregrine's top speed. To answer that question, Ken assembles a team of specialists and a very special falcon named Frightful. He'll test her speed with a lead-weighted lure that he'll release as he dives with her. A tiny computer like those used by skydivers is clipped onto feather shafts just under Frightful's tail coverts. Ken is confident it won't affect her performance. The Cessna strains in the thin air at 15,000 feet. Although wild falcons may reach this altitude, this is the highest Frightful has ever been in her life. Frightful is released. At 12,000 feet, she goes into her dive. After 10 seconds, she's going 120 miles an hour. Ken releases the lure. 21 seconds. Frightful shifts into hyperdrive. That's what Ken's been looking for. She shifts her shape to slip through the air's molecules. 43 seconds, she catches the lure, pulls out of her dive at 3,000 feet, and heads home. Moments later, Ken's chute snaps open. It looks like a perfect flight. The verdict is in. Frightful has broken her own record, and Ken still doesn't know how much faster she can go.
183 miles an hour.
Aerodynamically, they are the incredible contortionists. This is like karate in the air. I mean, what they do to hyper streamline, and then when they achieve high speeds, how they hold it blew us away.
1 week later, Frightful was clocked at an astonishing 242 miles an hour.
242 miles per hour. That is insane. Speaking of flying, let's do video question number 5. This involves not the speed of flight, but the length of flight. And it also involves migration that we will talk about later. And the question is this: what bird has the longest migration of any animal? The longest migration of any animal. And the answer is the Arctic tern. Arctic spelled, like just like Antarctic or the Arctic Circle, ARCTIC. And then it's the Arctic tern, TERN. And this bird migrates from the Arctic Circle to Antarctica and back every year. And so, depending on where in the Arctic Circle they're from, the ones that do the most, I think they spend the summertime, the northern hemisphere summertime, in the Netherlands, in this particular case of this one particular type of Arctic tern in the Netherlands. And then when winter is coming to the northern hemisphere, they migrate to Antarctica to spend their summertime, the southern hemisphere's summertime, and then they go back the next time the seasons change like that. And they each year migrate about 56,000 miles. 56,000 miles. And that also makes me think of like the albatross. The albatross is known for its gliding ability. An albatross can just soar without having to flap its wings for over 2 hours of just being able to soar. And oftentimes they have a good, like, what is it, 10 or 12? I'm kind of wanting to say 12-foot wingspan. Yeah, so all sorts of very, very impressive things that birds can do with their flight. But kind of going the opposite end of the spectrum, speed, not in terms of how fast it can move, but speed in terms of flapping its wings. The next one we have, I believe, is hummingbird. Yep. And this is just some slow-mo video of a hummingbird in flight. There's some kind of a feeder that is going down toward, and it's interesting the way that it flaps its wings, and I don't even know how slowed down this is. Hummingbird wings flap so quickly. It's amazing how just still its body is. It's doing all that flapping and his body is completely still. I mean, obviously it's moving a little bit as it wants to, but it can just hover there in place like that, despite all that wing movement. That also makes me think of this video that I saw of a type of bird that is able to keep its head just locked in on its prey. And there was a bird handler holding it, and the handler is moving the bird's body back and forth, but the head is staying completely motionless despite its body moving back and forth as his head and his eyesight is just fixed on something it's looking at. All right, that gives you a little look there. I don't remember how long this one is. I think it's almost over, but I'm going to skip ahead. All right. Also on the topic of key characteristics, we can talk a little bit about bird appendages. And again, the wings come up, but in this case, the wing as a whole as opposed to just the feathers, and different wing shapes that birds have that vary depending on what type of flight the bird needs to do. And so it's like if it is a soaring bird, or if it is a fast flying bird, or if it's a bird that needs to maneuver a bunch, or if it's a bird that needs to fly long distances, they have different wing designs for the different wing shapes depending on what function the wing needs to help serve for the bird. But then foot shape is something else that takes on a unique shape depending on the function. So if you're talking about a bird that is a carnivorous bird, a bird that will regularly hunt things like squirrels um, or rabbits, things like that. There's just the shape of the talons that they have for being able to grab and pick up animals like that, versus the shape of the foot of a duck, where it's essentially serving as a paddle for swimming through the water, versus the shape of a type of bird that mainly is that mainly needs to be able to perch on the side of a trunk for like a woodpecker, be able to perch on the side of a trunk in order for it to peck into the side of a tree, stuff like that. And then something else that's pretty interesting about birds is that their head and neck almost kind of serves as another appendage at times. They have long necks, and the way that the vertebrae of their skeleton is designed, they have a tremendous amount of flexibility and movement that they can get with their neck in order to move their head in all sorts of different directions and shapes and amounts. And like a lot of you might be familiar that an owl, some species of owls can turn their heads around almost a full 360 degrees. We're not even talking 180, like full backwards. Most of you can probably get right about 90 degrees one side to the other, or a total of 180 degrees from one side to the other. But we're talking about an owl being able to go from basically looking directly behind itself one way. So, like, let's just say its head is turned around to the right, looking directly behind itself, and then sweeping to the left, farther to the left, and then going all the way back behind itself again. And then add to that the different beak shapes and what birds use their beaks for, and you have almost like a third arm in a sense. All right, moving on to just a little, I almost said bird's eye view. It was like, no, that I didn't intend it as a pun, and that's a little too obvious of a groaner, so I won't say that. Anyway, bird system. So first of all, a little bit about its digestive system. And we mentioned bill shape, the shape of its beak or its bill, and I have an image on the next slide that gives you an idea of some of the different bill shapes. But one of the things that helps birds with eating is a crop, and that allows them to store a little bit of food. And then their stomach kind of has two different sections to it. There's the proventriculus, and that's where a lot of the digestion via digestive enzymes takes place, digestive juices, acid. And then the gizzard does grinding, and we've seen that gizzard come up from earthworms to some other types of animals as well. And birds, a lot of the pecking that they do, sometimes it's going for food, oftentimes it's going for little bits of gravel or rock to swallow and transport into their gizzard to help grind up their food better. After the gizzard, there's an intestine that both does some more of the digesting and a lot of the absorbing of nutrients and absorbing of a lot of the water back into the body. And then the cloaca, it's where the kind of waste is briefly collected before it is released, and that's both solid waste and liquid waste. And so the cloaca collects waste from the intestine and from the kidneys. And so it's kind of helping with the releasing of what we would do, and both a bowel movement and urinating. Both of those processes are kind of happening, are being pulled together in the cloaca. All right, I mentioned bill shapes. Just a few of these wide varieties. You have, insect catching type of bills to grain eating type of bills, coniferous seed eating. In other words, eating seeds directly from conifers or like cone bearing trees. Surface skimming, nectar feeding, chiseling, fruit eating, raptorial, filter feeding, aerial fishing, scavenging, and each one has its own particular design that works well for the type of hunting and or eating that the bird does. All right. Kind of unrelated, but let's do video question number 1. There isn't really a super good place that this fits in. There is kind of actually, but that's okay. Number 1, of unnatural causes of death. In other words, outside of just like a bird dying of kind of old age, but it's not old age, it's something else that we'll talk about later. What is the number 1 killer of birds? And the answer is windows. Windows, as in like the window of a house, the window of a building. Estimated worldwide to be something in the range of like 90 million to 900 million birds each year die from flying into a window. It's kind of sad, but it happens. I was about to say, I even observed it happen one time at this place where I was working, but the birds just stunned for a while and it was able to get up and eventually go away. So yeah, number 1 of unnatural causes of death. What is the number 1 killer of birds? Answer is windows. Okay, moving on to the next bird system, respiration. And I have air sacs here. And so a bird's lung has all sorts of air sacs, but even air sacs extend into its bones sometimes, of additional places to receive oxygen in the air as it inhales. But an interesting thing about birds is birds oxygenate their lungs when they inhale and when they exhale. They have this special lung design that makes it so that both inhaling and exhaling brings fresh supplies of air into their lungs. And that also relates to the homework question that you have about heat, about body heat. We already talked about how down feathers help a bird raise its body heat by trapping the heat in. But then the bird's lungs, or respiration in the form of breathing in and breathing out, inhaling and exhaling, is a main way that birds release excess heat. So it helps them lower their body heat when they need to by dissipating or releasing heat by their inhaling and exhaling. And then that term syrinx, it's kind of similar to, in us, we have a larynx. You may have heard of like laryngitis, that's related to your larynx. Your larynx is your voice box. Well, with birds, they have a syrinx called their song box. And so the syrinx is what allows the birds to make the different types of noises or chirps that the birds make. And I have a video that we'll just kind of skim through some parts of it, of different bird songs. And each different species has its own different kind of sound. And then some of them have just like these elaborate songs that they sing. Others are really good, like crows. I'm pretty sure crows. No, ravens, like ravens and parrots and parakeets, at being able to imitate different sounds, stuff like that. All right, next, circulation and excretion. We mentioned earlier that because birds fly, they need a lot of energy. How do you make energy? But you need a food source and oxygen for creating ATP. And so, along with needing a lot of oxygen, you need to get ATP and oxygen to, well, mainly oxygen and food to the different cells of the body, and that includes circulation. And so, birds have large hearts. Relative to the size of their body, they have the biggest hearts out of, I think, out of all animals, at least all land dwelling animals. So yeah, biggest hearts. They also have very high heart rate and blood pressure. So heart rate for us, like you might recall from PE or something like that, that a maximum heart rate for a person is usually 220 minus your age, right? So if you're 20 years old, your maximum heart rate is 200. Maximum heart rate meaning that's about the highest that your heart rate can go before you're going to risk damaging your heart and possibly dying of heart failure. Well, a lot of birds have heart rates that are commonly in the 500 to 600 range. Even some hummingbirds, especially, crazy high heart rates. We're talking about heart rates around like 1,000 to 1,200. And that relates to the overall number one cause of death in birds is, from what I understand, heart failure. Eventually, just their hearts just give out because of beating at such high rates for so long. But then relating to the excretion, there is, I have that bullet point there, no waste storage. If birds had bladders for storing urine, or if they had like rectums for storing fecal waste before excreting it, that would just be unnecessary extra waste and or extra weight, unnecessary extra weight. And so birds are designed that they don't store their waste. When there's a little bit of waste ready to go, it just leaves. And again, they don't have a separate place for urinating and passing bowel movements. That's all in one place. And yeah, birds don't have control over that. So contrary to, like, I think there's a Far Side, the Far Side comic strip that is something like how birds see the world, and it's a bird's eye view, and a bunch of stuff has targets on it. Oh, park bench target, person's head target, kind of a thing. There have been a couple commercials that have been done based on that idea as well. But unfortunately, contrary to that kind of an idea, birds don't pick and choose when they drop waste. It just boom, it just happens. Oftentimes it happens right before they take off for flight as a way of getting. I think they might have a little bit of control for being able to get rid of some of their waste before they fly, but then other than that, it happens when it happens. And then senses. Usually, the sense of smell is pretty weak with birds. One of the exceptions is, what is it, the kiwi, I think, that is blind, and so they do their hunting by smell. But most birds have a pretty weak sense of smell. Instead, they usually have a very strong sense of sight, crazy good sense of sight, especially so for some of the birds that are carnivorous hunters and that hunt from a long ways up, and yeah, like they can see at like 200 feet the level of detail that we can see at 10 feet, kind of a thing. Speaking of sight, let's do video question number 2. And the question is, what animal has the largest eyes of any land animal? So we're excluding things like whales. Okay. So what animal has the largest eyes of any land animal? And the answer is ostrich. Ostrich. And that's spelled Ostrich. Ostrich. So even though other animals like an elephant is bigger than ostrich, ostrich has the biggest eyes out of all land animals. Again, that was number 2. Okay, so we talked about sight and then instincts. Most birds have very strong instincts, whether it be instincts to migrate or instincts to for mating rituals, instincts for how to care for their young, instincts for how to build a nest, all sorts of stuff like that. And then also very strong muscle coordination. The part of their brain that does muscle coordination is very large. And that's because of all the crazy muscle coordination that goes into flying well, like the way that birds have to do. Okay. Another video. Say video, it's still pictures with different bird sounds. I'm going to skip ahead to a couple others. That one is Skylark. Oops. That one is okay. And then speaking of bird senses, I also grabbed this one.
It tunes in to the empty landscape. The noise of wind and snowfall is filtered out. It's rustling that the owl is interested in. A false alarm, but it doesn't have to wait long. From deep under the snow, a lemming transmits a high-frequency rustle. And around here, the penalty for rustling is death. The signals are too weak for our hearing, but this owl has the ultimate amplifier. Its face acts like a satellite dish. The dish is formed by a ring of stiff feathers. They collect and channel sound inwards. The eyes look central, but the dish actually focuses on the ears. They are on the side of the tiny skull next to the eyes. The dish is divided by a line of bristles, giving stereo sound. It's like having a giant cupped hand behind each ear. To pinpoint the lemming, the owl must tune its receiver. The dish is moved, the eyes automatically follow. Too far, then back again. The lemming is now being totally reckless. Sound dish and eyes are now focused. From this point on, it won't look away until the lemming is in its talons. The sortie begins. The owl's approach is absolutely silent. Soft velvety feathers have serrated edges that simply caress the air. As a result, no wing flaps interfere with the lemming's transmission. The head remains focused at all times, even if it has to fly around obstacles. Beneath a carpet of snow, a stationary target is easy to hit. But it's not just a simple dive bomb attack. The head stays locked on until the last moment. Then the talons are raised into the line of the sound. Claws on each talon are extended, two above and two below, perfect for catching cylindrical prey. The lemming's number is up. Even if the lemming is moving, the owl can compensate. The owl hovers. It checks signal direction. The body twists and the talons are repositioned. When you're dealing with senses this sharp and specialized, physical defenses like snow can be useless.
All right. We'll see if that last one plays on the video because it's BBC, and so far most of the BBC stuff that I've included, I have had to trim out in order for YouTube to let it be uploaded. Anyway, we'll see. And then the last section from this part of the chapter, this is section 18A3, is about bird family life. And one of the things that comes up here is courtship. And a lot of bird species have relatively elaborate courtship rituals. And it's oftentimes the male bird who is trying to impress the female bird. And that's the reason why it's usually the male bird that is the more elaborate of the species, the more flamboyantly decorated of the species. So think like peacocks. It is the male that has the big fans of feathers, and it's all to impress the females in order for winning a bride in a sense. But then some birds have what are called altricial chicks, and then some have precocial chicks. Altricial are ones that hatch from the egg pretty quickly, and they're relatively naked. They haven't developed feathers yet, and pretty helpless. And the parents have to feed the young for them and protect them for a while before they can get out on their own. Versus precocial are much more quickly, they're more further developed. They're a little more ready to fend for themselves when they are hatched. And I have the term syrinx there, but that I think is just an accidentally leaving it on from a previous slide. Let's see. So next, a little bit about migration. And there are a couple of reasons why birds migrate. One is to have year-round warmth and food. So they'll migrate so that they can stay in a warmer climate as the seasons change, or along with the warmer climate, they can stay where there's more food as the seasons change. So year-round warmth and food. And the other reason is to have a good environment for raising their young. And that's kind of related to the first one. Warmth and food you would think would also be good for raising their young. But it is listed as its own separate reason. And then what triggers the instinct to migrate? And it's usually the length of day. And so they have an innate sense of how long the daylight was for any given day. And once the amount of daylight gets small enough, that usually triggers them to begin their migration. And a variety of ways that they can know where to go. It appears that a variety of species have a sense of being able to sense the Earth's magnetic fields and using that to decide where to go. And that kind of relates to pigeons. Homing pigeons were bred for their ability to find their way back home, even if they were taken a long ways away. And because of that, they've been used as messenger pigeons for a long time. And even in World War I and World War II, they have been used as important aspects of protection and messages. So, like, for example, most fighter pilots in World War II would take on their plane with them 2 homing pigeons. And the reason why, if they were shot down at sea or shot down behind enemy lines, they could put a little piece of paper into a little carrying thing that the pigeon had that had their location, the coordinates of their location, release the homing pigeon, and the homing pigeon had been trained to return to a certain, like headquarters for their side, and they could get that message. And for that reason, a variety of pigeons have won medals of honor, or there's also even a specific separate medal that the U.S. military has for animals that pigeons have won by far the majority of them. Some dogs, a few other kind of animals, like horses and a couple things like that. But this is number 3 of your video questions. Video question number 3. What type of bird was used extensively in World War I and World War II? And the answer is pigeon. 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 There's one in World War I that there was a group of soldiers, I think they were British soldiers, that were trapped and outnumbered, and almost certainly they were all going to be killed. But the pigeon that they had, cher ami, I believe, that was like my friend in French. The pigeon that they had was able to get to headquarters and notify that what was going on, and reinforcements showed up, and it saved the lives of something like 170 soldiers, something like that. All right, so that's that. And the next slide that I have, I believe, is the last one. I'll look at my slide count, and I'm not seeing. Oh, there we go. Yeah, so let me also do. No, I'll do it after the video. Okay, one more.
Here's a rare sight in Hawaii, an adult albatross on land. The Laysan albatross, with a wingspan over 6 feet, was born to soar. They're creatures of the wind, living in the sky. And there's some powerful trade winds here in the Hawaiian Islands to keep them aloft as long as they want. They only return to land to raise their chicks. The chicks are on a tight schedule. In just a few months, they have to develop the strength, stamina, and skill to take flight. As you can see, this is easier said than done. The closer they get to adulthood, the more pressure there is on them to fly. The fledgling aeronauts turn into the wind and launch themselves down the beach. Death lurks for those who don't make it. The birds that aren't quite airworthy have to plunk down in the gentle surf, where tiger sharks are waiting for them. The young bird tries with all its might to mimic its parents and get airborne. Tiger sharks consume 10% of all the albatross young in this colony. This drama plays out every year, and the sharks don't always win. In fact, sometimes the shark gives the albatross the inspiration to fly. Amazing what knowing you're about to be eaten can do for your motivation.
Yeah, that would be motivating to fly. I thought that this video had more of like the albatross getting going and just making it to fly to avoid, but I must have been thinking of something else. All right, video question number 4. Unrelated to what we're talking about here, although albatross does come up in what I'm just about to say, but the question is, what is a group of ravens called? What do you call a group of ravens? And the answer is a murder. A murder of ravens. M-U-R-D-E-R. A murder of ravens. So a murder. And other groups of birds and what they're called, I thought it was interesting. A group of owls is a parliament. A group of buzzards is a wake, which is kind of, a wake as in like a funeral kind of wake. And buzzards, they're scavengers. They feed on things that have died. A group of catbirds is called a mewing. I like the sound that a cat makes, mew. A group of eagles is a convocation of eagles. There's a flamboyance of flamingos, a flamboyance of flamingos, a pandemonium of parrots, a squadron of pelicans. Oh, it's pelicans was on here. I was thinking it was albatross, but never mind. And a confusion of warblers. But again, ravens is a murder. Okay, that is it. Oops, sorry. That is it for birds. So, yeah, we'll see what we get into next time. But that's it for biology for this week. Hopefully these are continuing to help with your homework questions. If you're not, I do recommend you watch the videos with your homework questions in mind and maybe even pause it and write down the homework answers, because I'm covering most, if not usually all, of the homework questions. I'm answering them in the content of these videos. So my plan is to help you with that. All right, I'll see you next time.